Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us first understand the key concept here. In E2 elimination reactions, the ratio of SATSEF, more substituted internal alkene, to Hofmann, less substituted terminal alkene, products depends on the nature of the leaving group and the base used. The key principle here involves the C-X bond length and the E2 transition state geometry. Step 1. SATSEF versus Hofmann selectivity in E2. The SATSEF product, more substituted alkene, is thermodynamically more stable and is favored when the leaving group departs more readily, i.e., is a better leaving group, and when the transition state is more product-like or when steric effects are minimal. Step 2. Effect of leaving group on product distribution. For E2 reactions with a given base, the leaving group ability order is IBrClF. When the leaving group is a poor leaving group, like F, the C-X bond is very strong and has a short bond length. In the E2 transition state with a poor leaving group, the transition state is more carbanion-like or has more E1CB character, meaning the base abstracts the proton to a greater extent before the leaving group departs. This leads to a more planar, less hindered transition state that favors removal of the more accessible, less hindered proton, giving the Hofmann, less substituted product. Conversely, when the leaving group is excellent, like I, the C-X bond breaks more readily, the transition state is earlier, more reactant-like, and the more stable SATSEF product is favored because the reaction follows the thermodynamic preference. Step 3. Answer to Part A. Maximum SATSEF product. Maximum SATSEF product is obtained when the leaving group is the best, most readily departing, which corresponds to X is equal to I. Iodide is the best leaving group among the options. With iodide, the E2 reaction proceeds with the least E1CB character and the more substituted SATSEF alkene is the major product. Answer A. Option A. X is equal to I. Step 4. Answer to Part B. Hofmann product is major. Hofmann product is favored when the leaving group is the poorest, i.e., when there is the most E1CB character in the transition state. Among the options, F is the worst leaving group, C-F bond is strongest, shortest. With X is equal to F, the transition state resembles E1CB, carbanion-like, and the base preferentially removes the less hindered, more accessible proton, giving the less substituted Hofmann alkene as the major product. Answer B. Option D. X is equal to F. Step 5. Why other options fail for Part B? I, Br, Cl are all better leaving groups than F and would give increasing amounts of SATSEF product relative to Hofmann product. Only F gives predominantly Hofmann product due to its poor leaving group ability and the resulting E1CB-like transition state. Therefore, the correct answer is A, B, D. Therefore, the correct matching is A matches A, B matches D.